Hi, welcome to another video on my Arduino Mega2560 with pulse width modulation and some circuits of electronics. Last time I connected this LED with this resistor, that is this resistor, so these LEDs are acting the same. On the other side of the circuit, the frequency is not the same at all, while it should be. And I have two different circuits. Previously I already removed the capacitor. I want to notice what the difference is on this motor with propeller when I remove the transistor. In the very beginning I put the transistor in because of the motor, but I have been able to get a good result with that. And since this motor is supposed to be a pulse width controlled motor, I will see how that ends up without the transistor. So first of all, I am going to remove or replace this resistor. Is that a good thing to do? Well, there is still, of course, the inductor here, and I think taking this transistor out and reposition this resistor will do a fair amount of job. I think so. So I'm taking this transistor out, then taking the resistor away and put it here. So now the now this is one uninterrupted circuit, but the motor still doesn't run. Even worse, when I give it a hit, it doesn't keep running. So that is one thing, it doesn't do so. And to see if there is any change to the voltage, I take a multimeter and probes, and I think, okay, this is the mass, and this is the voltage, what voltage is on it, and that is about 4.5 volts. Is that enough? Not quite sure. But what I do notice, as you noticed as well, is as soon as I put the transistor out of it, it's not working anymore. How is that possible? Is the voltage too low? Possibly. So I will remove this resistor, and I will put this jump wire in, measure again. And it still gives 4.5 volts, so that is not a problem. Will this measuring here at this side of the resistor mean something? No, it's 3.5 volts. And here it says 4.5 volts. So that is something very peculiar. I have to take a closer look at that problem. Then it is time to measure from begin to end. Once again, probe on the mass, and this circuit is coming from right here. And I have to keep in mind that I don't disturb the other wires. And I measure from here, and it is 3.3 volts. Measuring again at the end of the wire, it says 3.3 volts. Then when it leaves this inductor, it says 4 volts. And with the motor it says 4 volts. So with that idea, I should actually remove this jump wire from that location and put the transistor back in. So let's remove it, and let's see how we can do it nicely. First of all, this transistor back in. Oops. That is one. And then a short jump wire. Between these, and you see it is already running. So the transistor is absolutely necessary for this to work. And here is the resistor that was in the circuit. So with that transistor this will not work. Which answers also the question about this LED and motor. This motor will not work without the transistor. Which leads to another question. Once again, what is the frequency? Or more appropriately, what is the voltage now? Let me measure that first. So, probe on the ground, and and the probe here on the transistor, which says barely 3 volts. This very peculiar. How can this be? Is there even contact? Yes, there must be contact. On the other hand, this is the plus, not the minus. So what's going on here? Oops. What is the plus? What is everything doing? Let me measure the frequency once again. Right here, 7 kilohertz. So it kind of looks like that I need to reconsider that part of the circuit. What is it doing? How does it work? This one as well. There is clearly voltage over it, over this LED from the transistor, but also between the transistor and this motor. So quite peculiar. So apart from the voltages, what are the frequencies? One probe to ground, and then measuring here gives 200 Hertz. Measuring here gives 30 Hertz, which is exactly as I have programmed. Let's measure here is 60 Hertz. Let me measure here is 30 Hertz. Measuring very carefully now at the end of the line, so this is actually straight on the board, 30 Hertz. The other line, this one, also straight from the board, 60 Hertz. And this one with 30 Hertz is coming from, let me reposition the camera. So the 60 Hertz is coming from here, and 30 Hertz is coming from here. And everything should be 30 Hertz. Does this make sense? No. None at all. Ground, measuring again. 30, oh right, this one is 30 Hertz and this one is 60 Hertz. Okay, so I mixed them up, but 30 and 60, which does not make sense at all. Everything should be 30. So it is actually time to to take another look at the code if I have made a mistake somewhere, which is always possible. But it's quite peculiar that I apparently do need the transistor to keep the motor running. While lower than 30 Hertz, and that was also a point, because one of the settings is, one of the possible settings is 20 Hz or lower, and then the motors didn't work. So it's a combination of the transistor and the frequency that make them work, which implies, because of the frequency, that the pulse width modulation does play a role. The question is, what about the combination? And yeah, let's take a look at the code. So, taking a look at the code again, this is the part for the pulse width modulation, and then we see that these are the pins which are being addressed, and the prescaler is taking care of the frequency. And last time it was noticed clearly that when I set the prescaler to 6, the motors stopped working. So from prescaler 5 and up, and lower I should say, it works. However, I need a prescaler of either 4 or 5, considering the range of the motors. And that said, the pin where it does not work anymore is pin 4. At least it does work, but it gives a wrong frequency. And pin 4 is this line, and it which is this line, and it also sets pin 13, which is not connected. So what I can do is put a wire from 13 to whichever available line and measure there. If that one is wrong as well, there is a problem. If that is right, if that is wrong as well, then I know that this prescaler for this register has a problem. So that is worth to find out. The other one is going to pin 2, and 3 and 5 are connected as well, but those 3 and 5 give the correct frequency. So then it should only be this one. Can I check it on another way? No, the others have the right one. Then it should only be this, which is quite odd in itself as well. And let me look at the rest. So this sets a prescaler, and this uses the sensor value from the analog in pin, which is analog in pin is A0, which is coming from the switch. So everything gets this output now. So everything, and then it's only the prescaler that makes sure on which pins a certain frequency is set. So yes, I think that is the next test to do. Pin 13. So a new jump wire, which I put here, let me show clearly, which I put right here. And then it is not even necessary to put it into the breadboard, because all I have to do is connect a probe to it and look at the frequency. It shows. Connect to the mass. And I don't believe that value. So let's take this mass point. And it shows an unbelievable frequency. Let me show you. Slightly more comfortable look probably. So let's take the mass and the end of this wire, and it shows an incredible 14 kilohertz. So I do not believe that. I'm taking another look at mass and one of these wires, and this one says, I don't believe that one. Neither do I believe that. Something odd going on here. Very odd. How come that I first measure the correct value of 30 Hz and now something quite odd? Contacts, I don't know. Let me take a try again. 30. Then this is 60. Yes, thank you. Now for the wire. And it's way off. Back to here. Okay, proof that something is not quite as it should be. Is my information wrong? My information could be wrong, but I doubt it. 4 and 13 should be the same. Is it? I have serious doubts. How can 4 and 13 give very different values? Okay, back to the start, back to research for information. Because this can't be. So, once again, a look at the code. According to all found information, timer 0 gets erased, and timer 0 is for pins 4 and 13. Prescaler sets the frequency. In this case it's 30 Hz for prescaler 5. Then back to timer 0. This is the logical AND this is the logical OR. It's bit masking. If you want to know what bit masking means, please see the internet. It's you can find it. And this is using C. Anyway, this is setting the prescaler of 5 being 30 Hz. This is old information because this was previously prescaler 4, but they set the 30 Hz on pins 4 and 13, and as just measured, 4 and 13 give a very different value, which raises the question, are 4 and 13 indeed connected? I only found timers 0. No, that's not entirely true. I found timers 1 through 4, 1, 2, 3 and 4, and timer 1, which I have not used, is for pins 11 and 12. Pin 2, timer 2 is for pins 10 and 9 and 10. But I have not used pins 9 and 10, and neither do I use oh, there's one other thing. I do use pin 11, but for pin 12 I have used for the input from the switch, so it is not an output for me, it's an input for me. Hence I don't need to set a frequency on that pin and line, which leaves timers 0, 3 and 4 for me, because those are the pins that I need to set. Does this solve everything? No. Still raises the question on 4 and 13. I need to find it out. I will do that at a different time. But so far it gets clear that it may explain why things go not the way I had hoped. And with this I end my video and this episode on my Arduino Mega2560 with pulse width modulation. Thank you for watching. If you like this video and are going to watch more videos of mine, please support my blog and videos by allowing advertisements in between the video segments. If you don't want that, please see my website, which is listed under this video, for information how you can support via PayPal. And for the rest, thank you for watching. Please subscribe to my YouTube channel, and this topic is certainly going to be continued.